Okay, today we are looking at the Chapter 6 test review. And so the first section of this review says determine if the following figures are polygons. If they are, then A, name the polygon. B, state whether it is concave or convex. And C, state whether it is equilateral, equiangular, or regular. So remember, to be a polygon, it's got to be a closed figure made up of straight segments. And when I look at this figure right here, there's a straight segment. This is not a straight segment, this is a curve. So automatically this means anytime you see anything curved on a figure, it is not a polygon. All right, so then next one, we've got a closed figure made up of 1, 2, 3, 4, 5 straight segments. So that will be a polygon. And so name the polygon. 5 sides is a pentagon. The B question says state whether it's concave or convex. So remember, convex means that if I extend the sides, none of the sides end up going into the interior of the figure, right? Which is the case here. None of those lines extend into the inside of the figure. They all go to the outside, so that makes it convex. And C, is it equilateral, equiangular, or regular? So equilateral means all the sides are the same length, which clearly this side here is shorter than any of the other sides, so it can't be equilateral. Equiangular means all the angles are the same, which all 3 of these angles appear to be right angles, but then these 2 up here do not, so it can't be equiangular. And then to be regular, it has to be equilateral and equiangular. So for this one, it's none of those. It's not equilateral, equiangular, or regular. Next figure. All right, it's a closed figure made up of straight line segments. So it would be a polygon. Now we count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 sides. And so when we name this, since it has more than 13 sides, we just use, or more than 12 sides, we just use the number of sides, 16, and we put gon after it. So it's a 16 gon. B part of the question, is it concave or convex? Well, if I extend the lines out here at the end, they go to the outside. However, if I extend here on the inner points, they go to the inside. So anytime you have a line that goes to the inside, that makes it concave, like you're going into a cave, or the figure is caved in, right? So then, last part, is it equilateral, equiangular, or regular? Well, all of these sides appear to be the same length, so we can call that equilateral. And then for the angles, all of these angles out here on the tips appear to be the same. The problem is there are other angles here on the ones that are coming to the inside that are not the same as the ones on the tip. So that means that there's 2 different angle measurements at least. So it can't be equiangular, which then means it can't be regular. So it is equilateral though. All the sides were the same. Next one. 1, 2, 3, 4, 5, 6 straight segments making a closed figure. So that's going to be a hexagon. Concave or convex. If I extend the sides, all the extensions go to the outside, so that's going to be convex. And lastly, equilateral, equiangular, or regular. All right. All 6 sides seem to be the same length, so it's equilateral. This angle, every angle looks like the same measure of angle. So this will be equilateral and equiangular. And when it's equilateral and equiangular, the right word is regular. So that's that section. Next section, we're going to find the sum of the interior angles for each polygon. So the sum of the interior angles follows the formula n minus 2 times 180. So n represents the number of sides. So first thing we got to do is count the number of sides. So we got 1, 2, 3, 4, 5, 6, 7. So our n is going to be 7. So n minus 2, 7 minus 2 times 180, which will be 5 times 180, which is going to be 900 degrees. All right, next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So it's a decagon. N equals 10, so we're going to do 10 minus 2 times 180, which is going to become 8 times 180, which is going to give us a total of 1,440 degrees. Next one doesn't give us a picture, but it tells us it's a 23gon, so we know our n value is 23. So for the math, n minus 2, 23 minus 2, times 180. That's going to be 21 times 180. And if we do the math there, 21 times 180 is going to be 3,780. And that's degrees. All right, so then the next one. Find the measure of one interior angle for each polygon. So the formula we're going to use to find one angle starts off just like we did here. N minus 2 times 180. But then we're going to divide it by n, the number of sides. So, coming here, start by counting our number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n equals 12. And so if n equals 12, then we're going to do 12 minus 2 times 180 over 12. So that'll be 10 times 180 divided by 12, which is going to give us 1,800 over 12, and we divide 1,800 by 12, 150 degrees. So each one of the angles inside of that dodecagon is going to be 150 degrees. Next figure, count the sides, 1, 2, 3, 4, 5. So n equals 5. So set it up, 5 minus 2 times 180 divided by 5. 5 minus 2 is going to give us 3 times 180 over 5, which is 540 over 5. And we divide 540 by 5, we're going to get 108 degrees. All right, next one, a regular 17 gone. So easy enough, n equals 17. So we're going to do 17 minus 2 times 180 divided by 17. So that's going to be 15 times 180 over 17. And if I do 15 times 180, that's going to give us 2,700 over 17. And 2,700 divided by 17 is going to give us 158.8 degrees for each angle. Okay. So next section, find the measure of one exterior angle for each polygon. So exterior angles are actually pretty simple, right? If it's a polygon, all the exterior angles add up to 360. So if I'm finding one of those, 360 divided by n is the formula I'm going to use here. So count the sides, 1, 2, 3, 4, 5, 6, and equals 6. So that's just going to be 360 divided by 6, which is going to give us 60 degrees. All right, next one. 1, 2, 3, 4, 5, 6, 7, 8 sides. N equals 8. So 360 divided by 8 is going to leave us with 45 degrees for each angle. All right, the regular 14 gone. So our n is going to be 14. Simply 360 divided by 14. And if we divide 360 by 14, that's going to give us 25.7 degrees. So on exterior angles, the more sides, the smaller the angle is going to be. On interior angles, the more sides, the bigger the angle is going to be. Just a little rule to follow. All right, so next one, classify the following quadrilaterals. So these are all quadrilaterals, so we're going to just state what specific name matches it. So this side's parallel to that side's parallel to that side. So it is a parallelogram. And then we've got right angles. So a parallelogram with right angles becomes a rectangle. And then if it had all 4 sides the same, we'd call it a square, but there aren't 4 sides the same. These 2 sides are the same as these 2 with right angles, which means that this is a rectangle. Next one, it's got 4 sides, quadrilateral. This side opposite that side does not seem to be parallel. This one doesn't seem to be parallel to that one, so it doesn't fit into the parallelogram. And then we've got this side and this side that are different, or this angle and this angle are different angles. These 2 are the same angles. Along with these 2 sides up here are congruent to each other, consecutive sides that are congruent. And down here, these 2 consecutive sides are congruent to each other. So this follows the definition of a kite. Next one, this side's parallel to that side, this side's parallel to that side. So it would be a parallelogram. But then we see that all four sides are 7 units long. So a parallelogram where all four sides are the same length becomes a rhombus. If there were right angles at each one of those angles, it would be a square, but those are not all right angles, so we just have to leave it at rhombus. All right. Next figure says state all the possible names for this figure. All right, so starting off, it's got 1, 2, 3, 4 sides, so that makes it a quadrilateral. And then we notice it's got arrows, single arrows on these sides, double arrows on these sides, saying that these two sides are parallel and those two sides are parallel. So that makes it a parallelogram. All right. No right angles, so it can't be a rectangle or a square. And then no congruence marks to say that all four sides are congruent to each other, so it can't be a rhombus either. So this is as detailed as we can get: quadrilateral and parallelogram. All right, so next figure, find the value of x. It's a quadrilateral, specifically a parallelogram. Opposite sides are parallel. And we're looking at consecutive angles, one angle that comes one after the other if we're following it around the figure, right? And when you have consecutive angles, those are going to be supplementary. So to set this up, we're going to say x plus 62 equals 180. Subtract the 62 from both sides. And x is going to be 118 degrees. All right, next one, another parallelogram. And technically we are looking at two consecutive angles. Just this angle is split into two parts, but x and 42 go together to make this angle. So that angle is x plus 42. And if we take this angle and we add it with this angle, since those are consecutive angles, one right after the other as we go around it, when we add those to that angle, the total has to equal 180. They're going to be supplementary. So x plus 144 is going to equal 180. Subtract 144 from both sides, and we're going to get x equals 36. All right, next one, another parallelogram. Opposite sides are parallel to each other. And this time we're looking at angles that are on a diagonal from each other, or we would call those opposite angles. And in a parallelogram, the opposite angles are going to be congruent. So to solve this one, we're going to say 2x plus 4 is equal to the 58. Those two angles have to be the same, so we set them equal. Subtract 4, 2x equals 54. Divide by the 2, and our x value is going to be 27. All right, so the next one, this time we're not looking at angles, it's still a parallelogram, but this time we're looking at opposite sides. And if it's a parallelogram, then we know that the opposite sides are going to be congruent. All right, so these two sides, to solve for x, we're going to set them equal to each other. 3x plus 5 has to equal 4x minus 1. Subtract 3x from both sides. 5 equals x minus 1. And we're going to add that 1 to both sides. And our x value is going to be 6. All right, finally a different kind of figure. This time we've got a trapezoid, and we're trying to figure out the length of x, which is on a mid-segment. And so the rule is that the mid-segment, which is the x, has to be equal to half of the sum of the two bases. So base 1 and base 2 added together. So 17 plus 22. So x is going to be 1/2. Add those together, we get 39. And half of 39 is going to leave us with 19.5. So the length of this segment here is 19.5. All right, another trapezoid. Tells us that these sides are congruent, so we know it's a isosceles trapezoid. And the rule in an isosceles trapezoid is that the base angles are going to be congruent on each base. So that's x there, which means that the other angle has to be x. This one's 77, so the other base angle on the bottom has to be 77. And then if we combine a base angle from each base, so 77 and x, those are going to be supplementary. So x plus 77 equals 180. Or it's a quadrilateral, you could add all four of them together and set that equal to 360, but it's a little more work than you need. Subtract 77 from both sides. And our x is going to be 103. All right. Final section here, find the area of the following figures. So we have to recognize the figures so that we know what formula we're using to solve for area. Here we have a rectangle, which is in the parallelogram family. Let's say that right. So area here is base times height. So our area is going to be 12 times 7. This base times that height. $84. There are no units given to us, but to make sure that we know that any units would be squared, we're going to put u squared on there to represent units squared. All right, so then the next one. All right, so one set of parallel sides. These two sides are not parallel to each other, so this is a trapezoid. And so the area formula for a trapezoid is area equals 1/2 of the height times the sum of the bases, base 1 plus base 2. So in this figure, 16 base 1, 21 base 2, and then they've got two numbers here, so we have to recognize that the height is going to be the distance that forms a right angle from the top to the bottom, which is going to be the 6, not the 8. So that's our height. So area equals 1/2 of 6 times 16 plus 21. So area equals 1/2 of 6, which would be 3. 16 times 21. It's going to be 37. So our area, 3 times 37, is going to be 111. And once again, it's an area, so we're going to put u squared on there. Next one is a parallelogram. In this case, we see that all four sides are marked congruent, which means this is a rhombus. Now, the measurements they gave us are not on the sides. The measurements they gave us are on the diagonals. And so the formula for a rhombus, or the area of a rhombus when we are dealing with the diagonals, is area equals 1/2 of diagonal 1 times diagonal 2, right? So we multiply the diagonals and divide it by 2, basically. So now our diagonals here, you've got 12 and 12. So this diagonal here, it's going to have a total of 12 plus 12, which is 24. The other diagonal here is 9 and 9. So 9 plus 9 is 18. So plug it into the formula. Area equals 1/2 of 24 times 18, which would be half of 24 is 12 times 18. And if we multiply 12 times 18, we're going to get an area of 216 units squared again. Now remember, if there was feet or inches or whatever mentioned on these, then you would use those units, inches squared, feet squared, whatever. But since these were not given with a measurement included or a unit included, we just put u squared to represent whatever units they are would be squared. All right, so lastly, a triangle. So formula, area of a triangle, 1/2 base times height. So we've got all 3 sides listed. So we've got a right angle right here. So this line right here going from this vertex to this side, making a right angle, could be our height. And when we go from that vertex to this side, that makes this side the base. So 17, we don't use it in this problem. So base is 13, height is 8. So area is 1/2 of 8 times 13. Or 1/2 of 104. Do the math right in my head there. All right, so 1/2 of 104 is going to give us an area of 52 units squared. All right, so that concludes the review. Hopefully all those made sense. Might go back through and re-practice those, or make sure that you understand the ones that you might have missed as you went through. So good luck on the test.